Okay, I hope I'm audible to all my students who are attending this particular lecture for the BBE Honors Statistics for Business Economics Part 1 course, which we cover in semester 2. Okay, in this particular lecture, I'm going to start with the discussion of the 2024 question paper, which has come up for the Statistics for Business Economics Part 1 course. And this lecture is particularly recommended for all those students who are pursuing bachelor's in business economics from University of Delhi. Okay, so scrolling down the question paper, the students can first of all look at the pattern of the question paper, that you need to write your roll numbers and everything. That is something which I don't need to discuss much. You need to attempt all questions. Okay, there are choices in every question. However, in my lectures, I will be solving all problems irrespective of the choice. You are allowed a simple calculator in the exam. So you are not allowed a financial or a scientific calculator. Please note, you are allowed only a simple calculator in the exam. The exam is for 90 marks. Okay. The final exam is for 90 marks for this particular paper. And in the exam, you will also be provided statistical tables. For various statistical distributions, students will be provided statistical tables in the exam. Okay, so in this particular lecture, I'm going to start with the discussion of problems from question number 1. Question number 1, we need to do any 3 questions. Every question is for 10 marks. So 3 times 10, question 1 total is for 30 marks. Any 3 questions have to be attempted. I will be doing all of them for discussion, but we need to do any 3 in the exam, and every question is for 10 marks. Okay, so let's quickly start from the discussion of question number 1 in this particular lecture. So let's read question 1, part A. A sample of daily earnings of a food vendor on a street outside a college was collected for 300 days. So we are given a sample of the amount of daily earnings a food vendor can earn outside a college. We are given the distribution of earnings as follows. So we are given so it's a continuous distribution. All students can see earning range in rupees, 100 to 200, 200 to 250, 250 to 300, 300 to 400, 400 to 600. You can see that the class intervals have different sizes. The class magnitudes are different. Okay, so it's a frequency distribution with I can say class intervals which don't have same magnitude, with different class magnitudes. Okay, number of days which are frequencies are given to us. So 40, 60, 50, 70, 80. These are the number of days given to us. That means on 40 days, on an average, on 40 days, the earnings are between 100 and 200. 60 days, the earnings are between 200 and 250. 50 days, the earnings are between 250 and 300. 70 days, the vendor earns between 300 and 400 rupees. And 80 days, he earns between 400 and 600 rupees. If you sum up the number of days, it comes out as 300. Okay, which is the total number of days given to us in the question. Now let us see what the question is asking us. On what percentage of days did the vendor earn less than 270 rupees? Now 270 will fall in this particular class interval. So we need to find out on what percentage of days. Now to do that, we need to first calculate the relative frequencies and the density, because density will capture the spread, which we can use to calculate the number of days, percentage number of days the vendor earns less than 270. So let me come to the whiteboard now. So coming to the whiteboard, I am writing the main heading first of all for completeness. This is Delhi University Bachelor's in Business Economics BBE Honors. We are looking at statistics for business economics. Statistics for Business Economics Part 1 course. Writing it for clarity, statistics for business economics part 1 course. And this lecture is containing problems we are solving from the exam 2024. Okay. Other students who have statistics as a part of your course can also benefit from this particular lecture, but students particularly having BBE honors at University of Delhi are going to benefit the max. Okay, so question 1 part A, I am first of all drawing the frequency distribution given to us. We are given the earning range in rupees, which is 100 to 200, 200 to 250, 250 to 300. Then we are given 300 to 400, 400 to 600. And we are also given the number of days, which are 40, 60, 50, 70, and 80. So these are my frequencies. Okay. Now, first of all, so the total frequency, the sum of all frequencies is 300. You can check that out. 40 plus 60 plus 50 plus 70 plus 80 comes out as 300. Now, first of all, I am going to calculate something called relative frequency. So, how do we calculate relative frequency? For the first class, it's the frequency of that class divided by total frequency. So I can say relative, I can write the formula on the top just for clarity. Students who have subscribed to my complete lectures for statistics for business economics, we have done these formulas in the main lecture as well. So relative frequency is nothing but frequency of that class interval. So relative frequency of a particular class interval, relative frequency of a particular class interval is the frequency of that class interval divided by total frequency. Okay, and to convert to percentage, you multiply by 100, but we are not looking at percentage. Okay, we are looking at absolute terms. So this is going to be 40 divided by 300. How much is 40 over 300? Students can quickly use a simple calculator and verify it's 0.133. So it's 40 over 300, which is 0.133. Then for the second class, it's 60 over 300, which comes out as 0.2. Then 50 over 300 comes out as 0.17. Then 70 over 300 comes out as 0.23. And 80 over 300 comes out as 0.27. These are my relative frequencies. Now we calculate density. So density is nothing but the relative frequency. I have covered this in the main lecture as well. It's the relative frequency over the class width or the class magnitude. So 0.133 divided over, what's the class width, guys? 200 minus 100, which is 100. So this comes out as 0.001. Here it's going to be 0.2 divided by, what's the class width here? 250 minus 200, which is 50. Comes out as 0.004. Okay, then it's going to be 0.17 divided by, what's the class width here? 300 minus 250, which is 50, comes out as 0.0034. Then 0.23 divided over 400 minus 300 is 100, comes out as 0.0023. And then 0.27 divided over 600 minus 400 is 200, comes out as 0.0013. So these are my densities or relative frequencies. Now the first part, if I come back to the question paper, what was the first part asking us? On what percentage of days did the vendor earn less than 270 rupees? So 270 means less than 270 means these two class intervals will be included for sure, because 270 lies in this class interval. So I can say that number of days in which the vendor earned number of days in which the vendor earned less than rupees 270 is 40 days where the vendor earned between 100 and 200, 60 days where the vendor earned between 200 and 250. Okay, and now 50 days the vendor earned between 250 and 300. That means if I spread this across 50 rupees, the extra earnings here is 300 minus 250. What's the class size here? 300 minus 250. The class size is 50. That means 50 over 50 times 270 is how much far from 250? So 270 minus 250 is 20. So multiply this by 20. I'm repeating it again for all students. Okay. We need to calculate the number of days in which the vendor earned less than 270 rupees. So 40 days the vendor earned between 100 and 200, that's less than 270. So 40. 60 days the vendor earned between 200 and 250, which is again less than 270, so plus 60. And now there are 50 days where the vendor earned between 250 and 300. That means if I convert into per day terms, it's going to be how much? It's going to be these. So these 50 extra earnings, you can see these are 50 extra. 250 to 300, 50 extra. These 50 extra are earned over a matter of 50 days. So 50 by 50 gives you 1, and for 20 such days, because I need to go from 250 to 270. I need to go from 250 only to 270. So how many extra rupees? 20 extra rupees. Okay. So that means that it's going to be 50 over 50, because you have 50 days. You have 50 days and you have to earn 50. You are earning 50 rupees in those 50 days. If you are in the 250 to 300 bracket. That means I am spreading 50 days. I am spreading 50 days over this particular class size. And then I am multiplying by 20, because from 250 I have to go to 270. So if I now find the answer, it's going to be 40 plus 60 plus 50 and 50 cancel. I get 1. 1 into 20 is 20. So my answer is how much? 120. 120 days is my answer. But the question asks in percentage terms, right? If you look at the question asks you in percentage terms. So I can erase the initial portion off and I can write on the top what is going to be the percentage number of days. If I erase this part off, I can write that percentage number of days when the vendor earns percentage number of days when the vendor earns less than rupees 270 is equal to, there are 120 days it earns less than 270 over total number of days 300, and now to convert to percentage you multiply by 100. So this cancels, I get 40%. That means on 40% of the days the vendor earns less than 270 rupees. This is my final answer for this question. So hoping all students have understood this. Okay. So basically relative frequency and density we calculated because we would want to now plot the histogram. If I come back to the question paper, it also asks us to plot a histogram. And since these are class intervals with unequal class widths, we calculated relative frequency and density. But to solve the first part, we don't need relative frequency and density. All we need is to work out the percentage number of days. So it's 40 plus 60 plus 50 days over this particular class size 50 and multiplied by 20, because from 250 to 270 we have 20 extra rupees. Okay, so I convert 120 days into percentage. How? 120 upon the total number of days, 300 times 100 gives me 40. So now coming back to the question paper, construct a histogram for the above data and comment on its symmetry. Now to plot the histogram, what do I need to plot? I need to plot the earnings on the x-axis and the density. I am repeating it again. What was the need to calculate density? We calculated the density because we had class intervals with unequal class widths. I am writing this on the top just for clarity. If I erase this initial portion off, since the data below, contains class intervals, since the data below contains class intervals with unequal class widths, why unequal? Because you can see in the first case the class width was 100, then it was 50, then it was 50, then it again came back to 100, last was 200. So if we see, the class widths are unequal every time. Therefore, we calculate densities. And now when we are going to make the histogram, we are going to plot the earnings along with the densities. So I am now erasing all this off. I am writing the data again. But this time I'm only writing the densities we got and the class intervals. So my earnings, the earnings are as follows: earnings in rupees, which are 100 to 200, 200 to 250, then we have 250 to 300, 300 to 400, 400 to 600. Okay, and the number of days are the densities. I'm only writing the densities now. The densities calculated are 0.0013, 0.004, 0.0034, 0.0023, and 0.00135. Now I'm going to plot the histogram. This was part 2 of the question. So let's plot the histogram. Okay, so we have on the horizontal axis, we have earnings. On the vertical axis, we have densities. Okay, and our class intervals are, they are starting from 100. So I can start from 0 also. So this is 0, then we have 100, then we have 200 with 1 centimeter gap, 100, 200, then we have 300, then we have 400, then we have 500, then we have 600. And for densities also, I can choose a scale. It starts from 0.0013, ends at 0.00135. So I can take the scale as 0.001. So 0.001, then we have 0.002, then we have 0.003, and then we have our last value is 0.004. So now we can plot them. 100 to 200, 0.0013. So 100 to 200, 0.0013 is slightly above 0.001. Slightly above 0.001, somewhere here. Okay, then we have 200 to 250. Now guys, 250 will be this, right? Between 200 and 300, you will have 250. So 200 to 250, 0.004. This is going to be 0.004. Okay, then we have 250 to 300, we have 0.0034. So slightly above 0.003. 300 to 400, we have 0.0023. 0.0023 from 300 to 400. And then we have 400 to 600, 0.00135. So it starts from here, 0.00135 will be slightly here, 400 to 600. So this is how the histogram is going to look like. And if you look at the skewness of it, you can clearly see that it's a positively skewed histogram. So comment on its symmetry. The question was asking us to comment on its symmetry. If you look at the histogram, it's positively skewed. If I take the midpoints of it and if I join them, you can clearly see it's like a positively skewed histogram. So I can write clearly the histogram has a longer tail to the right. Hence, it is positively skewed. Hence, it is positively skewed. If I take midpoints, and if I join them using a freehand, looks somewhat like this. So it's a positive. It's coming like a positively skewed distribution. Now I'm not using any scale. I'm just using a rough hand to join the points. Okay. So you can clearly see that it's a positively skewed histogram. Okay. So with this, we are done with part A of the question. This was the first part. Okay. If I scroll up the question, we have done part A. Part A had further two parts, part 1 and part 2. Now I'm moving on to question 1, part B. We are still on question 1. Given the following data, they are given the data 15, 13, 18, 14.5, 12, 11, 8.9, and 8. So it's a series of individual observations, basically. Okay. Determine the values of sample mean and sample median and 12.5% trimmed mean and compare these values. So it's a very easy and a direct question, I'll say. Okay. So let me first of all quickly come to the whiteboard to solve this. Question 1, part B. I'm quickly writing first of all the data given to us. It is 15, 13, 18, 14.5, 12, 11, 8.9, and 8. So can I first of all, so this represents a series of individual observations first of all. This represents a series of individual observations. Now let me first of all arrange this data in some order. So if I arrange the data in an ascending order, because to calculate median and trimmed mean, we need to arrange first of all the data in ascending order. For mean, we don't need to arrange it, but for median and trimmed mean, we need to arrange it. The lowest value is 8, then we have 8.9, then we have 11, then we have 12, then we have 13, then we have 14.5, then we have 15, and the highest value is 18. Now calculating the mean is quite easy. Mean x bar is simply the sum of all the x's over the total number of observations. So 8 plus 8.9 plus 11 plus 12 plus 13 plus 14.5 plus 15 plus 18 divided over how many observations? 1, 2, 3, 4, 5, 6, 7, 8 observations. So if I add all of them up, 8 plus 8.9 plus 11 plus 12 plus 13 plus 14.5 plus 15 plus 18 comes out as 100.4. Divided over 8 comes out as 12.5. That means the mean is coming out as 12.55. This is my sample mean X bar. Okay. How do we calculate the median? I use X tilde to denote the median. Okay. X tilde denotes the median. This is the size of n plus 1 by 2th item, which is the size of n is how much? N is 8. Remember? 1, 2, 3, 4, 5, 6, 7, 8. So size of 8 plus 1 by 2th item, which is the size of 8 plus 1 is 9. 9 by 2 is 4.5. So size of the 4.5 item, which I can write as the size of 4th item plus size of 5th item whole divided by 2. How do we calculate the size of the 4.5 item, size of 4th item plus size of 5th item divided by 2? So my median comes out as, what's my 4th item, guys? 12. And what's my 5th item? 13. So my median is 12 plus 13 over 2. Now if I work that out, 12 plus 13 over 2 comes out as 12.5. So my median is coming out as 12.5. And now we calculate the trimmed mean. Now, first of all, we need to calculate 12.5% trim mean. So, how do I calculate that? So, first of all, to calculate 12.5% trim mean, so I calculate 12.5% of the total number of observations, which are 8. Okay, so there are 8 observations, right? So, this is going to be 12.5 over 100 times 8. Let's calculate how much is 12.5 times 100. 12.5 times 8 is 100 over 100, which is 1. That means we remove the first observation and the last observation. We remove the first and the last observation to calculate 12.5% trimmed mean. Basically, we trim or we remove the top 12.5 and the bottom 12.5% of the number of observations. The number of observations were 8. So I remove the first and the last. So I remove this and I remove this. What is going to be my trimmed mean? So if I erase this off, my X trimmed mean at 12.25%, my X bar trimmed mean at 12.5% is going to be how much? 8.9 plus 11 plus 12 plus 13 plus 14.5 plus 15 over how many observations are there, guys? 1, 2, 3, 4, 5, 6. So I divide by 6 because I removed the first and the last. Okay, so if you use your calculator, you can verify that this comes out as 12.4. So the trimmed mean is 12.4. And now coming back to the question paper, what's the next part? How will the median change if the two observations 18 and 12 are changed to 20 and 14? So instead of 18 and 12, we have 20 and 14. That is very easy. Instead of 18, so first of all, let me remove this cross. We started, our original data was 8 and this was 18. And now the question says that 8 and 18 are removed by, let me correct myself, 18 and 12 are replaced with 20 and 14. So 18 and 12 are replaced with 20 and 14. So this is 20 and 14 will come after 13. So I can erase this also and I can write 13 here and 14 here. Basically, all we had to do was replace what was given to us with 14 and 20. Okay, so replace 18 and 12 with 20 and 14. So in the data, instead of 18 and 12, we have 14 and 20. So this is my new arranged the data. And now calculating the median is again very easy. We have to apply the same formula, right? The formula will not change. Our median x tilde will again be the size of n plus 1 over 2th item. The data is already in ascending order. N is 8. So 8 plus 1 over 2th item, which is the size of 8 plus 1 by 2 is 4.5th item. And we know that 4.5th item is the size of the 4th item plus size of the 5th item divided over 2. Now 4th item is 13, 5th item is 14. So 13 plus 14 over 2 comes out as how much? If you work this out, 13 plus 14 over 2 is 13.5. This is my new median. This is our new median. Okay. So with this, we are done with question number 1, part B as well. So I stop in this particular lecture. In the next lecture, I am going to start with question 1, part C. In this lecture, we have discussed question 1, parts A and B. I start with the discussion of part C in the next lecture. So I stop in this lecture. I hope all my students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. I once again repeat, students who are watching this lecture, if you want access to complete lectures, including theory and all practice material, just get in touch with me and I'm going to guide you about how to buy this particular course on my Econ DSC app. Okay, so this is where I stop in this particular lecture.